Destructors are unique methods in object-oriented programming. They are defined within a class and are invoked when an object is destroyed. Their primary purpose is to carry out cleanup tasks when an object is no longer active, relating to memory management. Destructors are rarely used in Python, as the language has a garbage collector for handling memory management on its own. The garbage collector activates when an object's reference count hits 0. It removes objects from memory that are no longer in use. The Python compiler performs this by monitoring each object's reference count, triggering cleanup shortly after it becomes 0. You aren't required to use the ~del statement to remove objects in Python. Objects can be created without manual deletion. If not deleted, Python cleans up these objects automatically at the program's conclusion. In large applications, this could lead to excessive memory use if not managed well. The syntax for creating a destructor is as follows: ~python def_del_self #body of destructor --. In this syntax, def * is the keyword used in Python to define a function. The method **del ** serves as a special method in Python for executing cleanup tasks related to memory management. The *self * parameter references a specific instance or object of the class. The destructor has one key parameter. *self * retains a reference to the class instance invoking the method. A destructor does not return any value. Now, let's explore some examples to better grasp how destructors work. Here's an example illustrating the destructor's use with the ~del keyword. Python #class student definition class student. Initializing the class def __init__ self print class student is created. Destructor definition def __del self print student class is deleted. Creating an object of the class and invoking the constructor. Python obj equals student. This line calls the destructor function. Python del obj the expected output is class student is created. Student class is deleted. In this example, a student class is created, along with its constructor and destructor methods. An instance of the class is created, followed by invoking the destructor function using the ~del keyword. Thus, the destructor method is automatically triggered because we used ~del to eliminate all object references. The next example shows that the destructor runs at the program's conclusion to handle cleanup tasks. Python #class developers definition class developers. #class constructor def __init__ self print developers class created. Class destructor def __del __ self print. The destructor is invoked. Python #function to create an object def create obj print. The object is created. Obj equals developers print. Function ends here. Return obj first. We print a message and then create an object. Python print call the create obj function. Obj equals create obj finally, we display a termination message. Python print. The program terminates here. The expected output is call the create obj function. The object is created. Developers class created. Function ends here. The destructor is invoked. The program terminates here. This example showcases a developer's class where both the constructor and destructor are defined. Next, a create obj function is defined to create and return an instance of the developer's class. Upon program execution, you'll observe that the destructor runs just prior to the last print statement. This occurs because the print statement does not produce any new objects or use any instances in memory. This illustrates that the destructor is called at the end of the program when there are no remaining instances in use. Now, let's look at an example of using a destructor in recursive programming. Python class recursion program definition class recursion program. Constructor definition def __init__ self. Num, self.num equals num print, defined variable for recursion num equals num. Python destructor definition def __del__ self print. Object of recursive function destroyed. Python recursive function definition def recurfunc. Self. Num equals none. If num is none. Num equals self.num if num.